I'm redoing my 9th standard on potential energy, and I'm doing number 96 of chapter 6 under comprehensive problems. And the problem says that a spring gun has a spring constant of 28 Newton meters that is used to shoot a 56-gram ball horizontally. Initially, the spring is compressed by 18 centimeters. The ball loses contact with the spring and leaves the gun when the spring is decompressed by 12 centimeters. What is the speed of the ball when it hits the ground 1.4 meters below the spring of the gun? So I tried to draw a little picture here. And I know the spring constant is given. The mass of the ball is given. I want to know the velocity. I got my height and I got 2x. And since it started with 18, but then it shooted at 12, I got the difference of 18 and 12, which give me 6 centimeters. And I like meters. Well, we like to use meters, so we convert it into meters. So I got 0.06 meters. And then for grams, we would like to use kilograms, so we convert it into kilograms. And then anything that has a spring is an elastic potential. It has elastic potential energy. So I'm using this equation here. And then once the spring is let go, it converted into kinetic energy. So I need these two equations, and since this is converted to this, it equals each other. So I got the elastic potential energy equals the kinetic energy. So I just use these two equations, make them equal each other, and then I want the velocity. So I'm solving for velocity. To solve for velocity, I divide it by 1/2 times mass to the other side, and then square rooted it. Plugged in my numbers, I came out with a velocity of 1.34 meters per second, which is my initial velocity. And they're asking for when it struck the ground, so that would be my final velocity. And to find my final velocity, I use this kinematic equation. I use V final squared in the y direction minus V initial squared in the y direction equals 2 times acceleration in y directions times the change in y, which is the height. And then I solve for VF. So I added the initial velocity squared to the other side. And then I square rooted it, plugged in my numbers, and I came out with the final velocity of 5.4 meters per second is when is the speed of the ball when it hits the ground. 1.4 meters below the spring gun. And that is how I solve problem 96 of chapter 6 under comprehensive problems for potential energy.